Hello everybody and welcome to another live training session with Unity. My name is Mike Geig and I am happy you all could be here today to learn about Nav Meshes. A lot of people in chat are asking me about a turkey. I guess the session description does mention roasting a turkey. We will not be roasting a turkey. I do apologize. For any of you who actually came here expecting to roast a turkey, yeah, you can you can leave now. I got to be careful with my own jokes, apparently. So today we are talking about Nav Meshes, which is basically a shortening of navigation mesh, and we are going to use those to move our character and enemies and all that stuff around the screen, and all around our levels, and it'll be pretty cool. Okay, before we start with that, like always, I'm just going to go ahead and toss this up here. Questions, comments, concerns, things like that. Feel free to follow us on Twitter at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at The Ant Ranch. And yeah, feel free to message me on there, or send me an email. My email is mike@unity3d.com or anything like that, and I will get you squared away. I have been getting a lot of recommendations through Twitter, so that's great. I do have several more sessions I want to get posted. I just have not done so yet. So I am listening to your guys' feedback. The stuff will come up and all that. It's just it takes a little bit of time in planning and preparation and all that stuff. All right. So today, let me remove this here. Today we are talking about Nav Meshes. We're talking about navigation, specifically Unity's built-in navigation, so you don't have to do all this stuff yourself. What I have here is I have the scene from our stealth project. So if you happen to have that, you can load it up yourself. But if you just go to the asset store and search for Unity Stealth or completed projects Unity Stealth, you'll get this game. And the game is a stealth game, and you got to hide from robots and avoid laser fences and all that stuff. And I've pretty much gutted out the game logic just so we have the level, because I don't really care about the game itself. I want to show you how to navigate around a complex environment, and so that's why I chose this. And you can see here, we have the character right here named Ethan, and we just have some lights and different stuff all over here. So we have this game. And right now we control the game through using, the controls like WASD. But a thought occurs, what if we want to control this character by clicking to move, right? All of a sudden things get a lot more difficult. We have to start dealing with navigation. Furthermore, if enemies are going to find the player and attack the player and stuff like that, the enemies are going to need to be able to move around the scene intelligently, right? And so we get to this issue of navigation. Now, there are a lot of different ways we can handle navigation, and we can do it manually ourselves. There's A*, there's tons of algorithms, and then there's the Nav Mesh, and there's a lot of different ways, and we're going to kind of look at some of the pros and cons of those. So some of the questions in chat: am I wasting my time watching this? I'm a newbie coder. Nope. This is still really cool. The coding is very minimal in here, so really don't worry about it. Yeah, and we'll talk about Nav Meshes versus like A* and stuff like that. So real quick here, let's talk about some different ways we can handle navigation. And I have this little graphic here. And basically, there are a few ways we can get a player to a target, right? So in this graphic, the player's little stick figure dude at the bottom, and the target is the map at the top. So the first way is we can always just move our character directly towards where it wants to be, in this case the flag. And as you can see in the far left, that doesn't always work because there might be things in the way. And so we might collide with those things, we might clip through those things, and so we need something to be a little bit more intelligent. Another thing we might consider is moving our character one step forward and then reevaluating where the enemy is and then moving one step toward the enemy and stuff like that, and avoiding walls, right? And that would work unless we had our character walk into a concave environment, like say the character walked through a door into a building and then was stuck because they wouldn't be smart enough to turn around, go back out the door, and come back around, right? So, always moving and then reevaluating, moving and then reevaluating isn't always necessarily a great way to go about it either, right? And then you might think, well, let's intelligently move them around with these paths using something like A star, which is a common pathfinding algorithm, and you can do that too. The difficulty is you get a situation like we have in the third image on the right, in that the movement will get you to the end, but it's not a very intelligent path, right? It's not very, what do I want to say? Well, it's not very efficient, and it doesn't give you a lot of the idea. It doesn't help you believe that the character is all that intelligent, right? Kind of hugging the edges of that building and whatnot, as opposed to just walking around the building like you normally would, like any person would just walk around the building. So we can kind of, come up with our own schemes of doing this, or we can just use Unity's built-in navigation, which is actually fairly powerful. There's a lot of curiosity surrounding it because it used to be a pro-only feature, but it's now available and free. Yeah, those are flags, not letter P's for path. Whoops. They're supposed to be flags. Anyway, so those of you using Unity Free can do this now. So it's not just a Unity Pro thing anymore, which is why I wanted to cover it. I try to avoid covering things that are Unity Pro only because I know a lot of you don't have it. So this will help, now there are some things that are Pro only, but there are more advanced features anyway, so stuff you're not really needing to mess around with right now. Okay, so let's talk about this. Now, what we could do is we could do a classical system of nodes and waypoints, or a system of reading our environment and trying to find colliders and things like that. Or we can do what's called a navigation mesh. And what a navigation mesh is it's effectively a flat plane. And by flat, I don't necessarily mean it's perfectly horizontal. It can be flat at a slope, like stairs and stuff like that as well. It's a plane where the points on the plane are used for finding a character's ability to move around. The reason we use nav meshes as opposed to just using the meshes we already have, like for instance, I could theoretically just use this mesh I have in the world here to find my navigation. The difficulty comes from the fact that this mesh, it has a lot of raised areas, lowered areas, ins and outs, and so finding a path along this mesh would be very inefficient. All right, because there's just so many like nooks and crannies and high polygons and stuff like that, the calculations would just take too long. And so what we're going to do is we are going to build a flat plane called a nav mesh that's going to be invisible. We're not going to be able to see it while we're using our game. And we're going to use that to do our calculations, which is going to end up being efficient and it's going to be very accurate. And it's something we can all kind of do, which is actually why I chose this environment. So let's look at how we do that. So the first things first, I'm going to want the navigation window. And I get to the navigation window by coming up here to Window and then selecting Navigation. And I'm going to get this new window over here where my inspector normally is. My inspector is still here. It's just a new tab right there. And this navigation window is going to allow me to build our nav mesh. All right. When we're building a nav mesh, it's called baking it. We're going to bake a nav mesh, which basically, is what's going to create it for us. So the first thing we have here is we have 3 tabs, and I'm going to kind of talk about the tabs, and then we're going to go. And we're actually going to use it. So the first is the Object tab. And the Object tab allows me to pick the objects I want to use when baking. All right? It finds me the objects and allows me to specify what about those objects I want to use. Next, we have the Bake tab, which has all of the, the properties of this bake. So the radius, height, max slope. We'll go through what these mean in a little bit, but that's what's the baking tab. And then we have the Layers tab. And the Layers tab is neat because it comes with 3 built-in layers, which is Default, Not Walkable, and Jump. And then it has a bunch of layers that we can specify ourselves. And the cool thing about layers is we can give to them a cost. And the cost is used for intelligent pathfinding. So for instance, let's say I have a scene where a player needs to get across a flowing river, right? And so what I need to do is I need to obviously cross this river. And if I build a nav mesh about over the whole scene, including the river, and I click on the other side of the river, the character might just try to walk across the river, right? That doesn't really make a lot of sense. I mean, it could work. You could move across the river, but ideally, the smart thing would be to allow the player to go up and around to a bridge and then come across the other side. So we might give the river a really high cost and the bridge a really low cost, which means the artificial intelligence is more likely to go the route of the bridge as opposed to fording a river and accidentally drowning or whatever. So we can use costs and layers to kind of associate that, or maybe like a heavy snowbank versus a road. Well, obviously you'd want to walk on the road, not the heavy snow, so we give the snow a higher cost and so on and so forth, and that's part of the calculation. All right, so I'm going to come back here to the object tab, and the first thing I'm going to do is I'm going to create a very simple example. We're going to turn everything into a nav mesh, and we're going to kind of see how it works, and we're going to see some of the limitations. So the first thing I'm going to do is, instead of seeing all, I don't want to see all objects. I'm only really concerned with the things that are meshes, right? I don't care about lights and all that stuff. So I'm going to click over here to Mesh Renderers, right there. And over on the left-hand side, all we see is every mesh renderer in our scene, right here. That's all of them. That's the different extents, that are grounds in here, decals, whatever. And I am just going to grab all of them. Now, this isn't necessarily a good idea, all right, but I just want to illustrate for you that I'm grabbing every mesh in this game. And I also have the Show Nav Mesh checked. So I'm going to go ahead and click Navigation Static. It's going to ask me if I want to change that for everything. I'm just going to hit yes. And my navigation layer is going to be default. Off Mesh Link Generation is something we'll talk about here in a little bit. So I'm just going to leave that alone. So again, I've selected everything, I've set it to navigation static, and my layer is default. Navigation static means it's not going to move as far as navigation goes. The walls and the floor aren't going anywhere. It's not dynamic, right? It's going to stay still the whole time, and so I can make them static. And then I am going to go ahead and click Bake. It's going to take a quick second. And we're going to see the ground turns blue. The ground turns blue everywhere that is walkable. All right, so everywhere my player can go is now blue. So the player can come up here, the player can go in this room, the player can come out here, even though the player can't actually come out here because there's no way for the player to get there because we have walls. But all of the places that are blue, player can come up here on top of this van, anything like that, the player can technically go to. All right, so really what we've done is we've just made a nav mesh. I mean, theoretically we're done. Right? I mean, it's really not that complicated, right? We've made a nav mesh. We can navigate around. And so what I'm going to do is I'm going to leave this alone, and I'm going to go ahead and build my character to be able to move around in this nav mesh, and then we'll use that to see some of the limitations. So I have my nav mesh done. It's baked. We can see it, the blue stuff. That looks great. So I'm going to come back here to my inspector tab, and I'm just going to click on my character, Ethan. And what I want to do is I want to make a script for my character Ethan. And my script is basically going to allow me to click to move my character around. Okay, so I'm going to come down here to the scripts folder, and I'm going to right click create a C# script, which I am going to call navchar script, just like that. And so we'll edit that in a second. And actually I'll go ahead and just pop this onto Ethan right now. So Ethan has a nav character script attached, which is what we're going to use to actually fuel this movement. But more importantly, the one thing Ethan really needs is what's called a navigation agent. All right, and it's that agent that's going to read the nav mesh and know where he can go and where he can't go. All right, and so what I'm going to do is I'm going to click with Ethan selected. I'm going to click Add Component, Navigation, Nav Mesh Agent. And this has some stuff we need to concern ourselves with. The first is the radius of this agent, right? Because we want to set it to however wide Ethan is, our character is. We want to know how fast the agent can traverse, and we want to know what the acceleration is, angular speed, how long it takes to stop, whether or not it'll traverse or auto traverse, braking, if it'll repath if a path breaks while it's in the middle, all of these things. Okay, these are all pretty basic stuff. It's your normal physics stuff plus the size and whatnot. Also, we have this obstacle avoidance quality. So if we wanted to set it to low quality, it would be much more efficient, but obviously it would run into more obstacles, right? Since this is our click to play player, I'm going to choose high quality so that we can avoid obstacles and not get stuck in corners and things like that. We obviously want this to be smart. We can also determine what the Nav Mesh guy can walk on, right? So he's able to walk on everything. All right, obviously you can't walk on not walkable, but it's still checked anyway because everything is checked. But like if I wanted this player to be able to avoid rivers, I might have a section of my Nav Mesh, one of my models on the river layer with a high cost, and I would just select or unselect that layer for the river, and then this Nav Mesh agent cannot go on the river or snow or fire or whatever I want. Yeah, but so we can choose what layers we can walk on and all these things. But realistically, the default settings are pretty good. The default settings are everything that I need right now, so I'm just going to leave them alone, right? Because it automatically came up with the right size, the right height, the speed stuff is good, the angular stuff, all that's fine. I want it to be able to walk on everything with high quality, so I'm not going to touch it. I'm going to leave that pretty much exactly the way it is. But now that the Nav Mesh agent's on there, I can begin programming to move my character via click. And you're going to see two things. One, moving via click is actually really simple. And two, using the Nav Mesh agent is 2 lines of code. And it's that simple. It's actually really, really easy. So let's go ahead and open this up. And I'll read the chat while I'm doing that. Okay, it's open up here. So a couple of things we need to do is we need to first have a variable to contain our Nav Mesh agent. So I'm just going to say Nav Mesh agent, which I will call agent right here. And then in the start, we are just going to say agent equals get component Nav Mesh agent. So there, now we have a reference to our Nav Mesh agent. So now all we really need to do is say, hey, agent, go to this place, and the agent will go to that place. It's that simple. And what's really cool about the agent is even if you tell it to go someplace it can't get to, it's going to go somewhere close in an efficient manner, right? So it's going to kind of figure things out, all right, which is really nice. So it does this automatic pathing. If the path breaks, it can rebuild it in real time, and all that stuff really, really quickly, all right? So now all we really need to do, most code we're going to put in here, oh sure, I always forget about the size of text. There we go. Okay. Why don't I change my keyboard? I said I was going to a long time ago and everyone told me to keep it. People like mechanical keyboards apparently. So yeah. So it's your own fault for me having this super loud keyboard. Yeah. So okay, so what I need to do first is I need to get a point to send my character to, right? And that's just going to be done with raycasting, that's really beyond the scope of this particular lesson. So we're going to go through it quickly, but we're going to raycast to find a spot, and then we're going to send everything to that spot, right? So what I'm going to say is if input dot get mouse button down. Oops, 0, there we go. So if I click the left mouse button, all right, if I get the left mouse button, or click the left mouse button, we're going to create a ray, called ray, and we're going to set that equal to camera, big C camera, not little c camera, dot main, dot screen, point to ray, and what am I going to point at? I'm going to point at input dot mouse position. I've done this particular bit of code before several times during live sessions when we did the lasers and when we did the explosions and stuff like that. So this isn't the first time we've seen this bit of code if you've watched any of the previous lessons. All right, let's see here. Mike the angry keyboarder. Yeah. So then we need to find out where we hit. So I'm going to do raycast hit, which I'll just call hit. And then finally, if we actually hit something, I'll say if physics.raycast, and I will pass in our ray. I will pass in by reference our raycast hit, and I'll just say 100 arbitrarily. That is purely arbitrary. I could have passed in 10 and that probably would have worked, but I picked 100. So if we have a spot, right, that we've clicked on, our rig was sent out to our mouse, it hit something on the ground, we now know where it hit. So here's where we're actually going to send the character. We're just going to say agent.setDestination hit.point. I did that backwards. Hit.point. Just that. That is it. That is everything required to move our character in a click and move game. All right. Now, if we had animations, we'd want to tie those in too. So you're going to notice my character doesn't move with animations. I could pull in a reference to the animator and just set its velocity in here and all that, but I really didn't want to get too far beyond the scope, right? So this script right here will give you everything you need. So we get a reference to our agent, or we have a variable for our agent, we get access to our agent, and we tell our agent where to go. 3 lines, right? Really 2 lines of code and 1 variable declaration. But there we go. So using that, let's go ahead and run our scene. So now we see our guy nicely idling there. I can control him using the keyboard. This is me using the keyboard to control him, right? That's just built in. That's on the character, whatever. I'm not super messing around with that. But better yet, when I click, he'll move. And like I said, there's no animation, right? But by clicking, he's moving. And furthermore, he can avoid corners. He can basically move all around. If I push him over here, he'll find the best path to get there. Right? So we have a click to move game. Really simplistically built. You'll notice, hey, there's a little tear in this fence. Can my guy get through there? Yes, he can. Right? So pathfinding works very well so far. All right? So we have a Nav Mesh, and we have just a simple Nav Mesh agent, and our guy's moving around. Now, that being said, let's look at some of the limitations of what we've done so far. So first off, I can't get past here for whatever reason, right? I can't move in there. All right, so let's try something else. All right, so I can't get past the lasers. Can I get past these lasers? I can't. Okay. Let me come over here. Let's see. The door is open, but I can't seem to go inside. So we can see that we have some issues, all right, that we need to address. I have some questions in chat here. Is camera.main an implicit get component? No. Camera.main is always available as long as you inherit from monodevelop. So you should always be able to do camera.main. Is it possible to define the position of the Nav Mesh agent on the Nav Mesh, i.e. for creating a city traffic based on the Nav Mesh? I'm not really sure what you're asking. The player, the Nav Mesh agent is on a game object with a transform, so it always knows where it is. Is that what you're asking? Or are you talking about waypoints? I'm not entirely certain what you're asking there. Let's see. How do I make an inventory? Way beyond the scope of this topic. Yes, this will be posted afterwards. I see people asking that a lot. These are always posted. They will always be posted. Yeah. Can you set up cost in a terrain asset? Yes, actually. For terrain, if I go to navigation, click terrains, I can select it and then put it on a layer with different costs and stuff like that. So yes, you can do that with terrain and everything. Okay, so and the rotation and all that stuff can be modified in code and through our settings and stuff. But okay, let's talk about what happened here. All right, so I'm going back to my navigation tab, and I'm seeing everything everywhere that I can walk, and it seems that I can go inside here and I can go in between here. But the problem, you'll notice, is that the blue boxes aren't connected, right? This is a self-contained blue box, and this is self-contained out here. So the player can't actually go through the door, all right? You can see the player can't actually go through the door, and that's the problem. The problem is also that the lasers are in the way, so the player can't actually go through them, right? So the problem was that we selected everything in our game and built our Nav Mesh with it, right? And we don't necessarily want to do that. We only want to build the Nav Mesh with certain items in mind, right? The items that are the ground. So what we need to do is we need to fix this. And how we fix this is by changing the items that are currently blocking us from being navigationally static to not being navigationally static. So let's look at this door. I'm going to click on the mesh renders, by the way, and I'm just going to click on this door. All right, and I see the door, and I'm going to expand the door parent object, and so I'm clicking on the door actual mesh. So this is a parent object, this is the actual mesh, and the mesh is the one I want. And I see that it is set to navigation static. I did that. I selected everything and set it to navigation static when I started. So I actually caused this problem, so let me fix it. So I'm going to uncheck navigation static, right? That means it's not a static object. That means it moves as far as navigation is concerned. So now I'm just going to click bake again. And what we see now is a path appears between the two rooms. All right. So, and actually, so someone in chat just said use the tutorial for coding if you want zombies to follow you. We're actually going to build that here in a second. So I will show you how to put enemies in your game and have them chase you around. So yeah, 1 second, or in a little bit here, I'll show you how to do that. It's actually pretty simple. So, okay, so now you can see here the character can move through it. And I'll show you. So I'll click play, and I'll just click over here in this room, and there goes my guy. And my guy's going to come around the corner here, and he's going to go through the door, and he's in the room. Fantastic. He's the clicking mechanic is kind of inaccurate because the camera is at an angle, so when he walked in was kind of running into these barrels and stuff. That's just because of how I handled the clicking mechanic, just because it's simple. Okay, so with that in mind, let's go ahead and grab every door and just quickly set it to not static. And now we can get into every room. That doesn't fix the lasers yet, so what we need to do is we need to find the lasers. Here are our lasers, and again, make them not static. And then they go away, and you can see our path continues through them. So now we have our path set up rather nicely. Furthermore, if I ever wanted to fix something like here, I don't want the guy to be able to walk on these crates. So I can click the crates. I can try to click the crates. There's the crate, and there's a crate, and I'll set both of those to static. Oops. And now, boom, the crates go away. We can no longer walk on the crates, right? So, again, building these is a part of figuring out where the player can go, and then just baking with that stuff and getting rid of the stuff where the player can't go. Otherwise, you're going to see the player able to walk on things that they're not supposed to be able to walk on, and they might get stuck. Like, the player can get behind these wires and stand on these crates, and that's not really anything that we want. So again, we'll just turn off static. We'll bake. They won't be able to walk on it anymore, and that fixes it for us. Okay? Another issue we have had is, or we might have, is that the player takes the corners too tightly and kind of collides with these little barrels, and it looks kind of jerky, right? So we can actually edit some of our settings to fix that problem. So I'm going to come back here to, I'm going to come to my Bake tab where all my stuff is. And the first thing we have is the radius. And the radius is how close we can get to objects in our game. And if our radius is really small, our character can bump into walls and stuff like that. You'll see if I set it to 0.1 and hit bake, you see everything gets really, really close. Now it's taking a while to build that because the radius is so small, but you can see the player can get really close to walls. And if I hit play, what we're going to see is that the player will collide with stuff and bounce and whatever and get stuck on corners, and that's no good. So let's instead set this to 0.6 and hit bake. Now we can't get as close to walls, all right, but we are able to get closer, or able to have smoother movements. All right. Someone said, won't they be able to walk under the area of the crates that I selected because that part was still blue? No, they will collide with the crates and they'll stop moving. All right, and so they will not be able to get under there. All right. So, okay. So now we've kind of fixed that issue, and we have, and I'll actually just run it again to show you. We now have smoother movement because we increased our radius. We can move through the lasers. Now, if this were the game, all the enemy robots would come start shooting me because I ran through the lasers here. But yeah, but we have nice smooth movement, and so far it's working rather well. Okay, so let's talk about what all these options do. So we talked about the radius first, and the radius is basically how close you can get to the walls without colliding into them. And then we have the height. And the height is the disparity between two items where you'll still be able to get on top of it, right? And I don't mean like the building height right here to the ground. I mean if we have two, say, plates on the ground close to each other, how close do they have to be before you can just seamlessly walk across them? And that's our height. You'll notice how the roof up here is blue and the ground here is also blue, but there's a break between them. That's because the height between them is so great. All right. Sorry, I'm kind of glancing over at chat and then back. Next, we have our max slope, and our max slope determines things like stairs. How steep do stairs have to be before they're not walkable anymore? Right? Or how steep does a hill have to be before it's not walkable, or a mountain, or anything that would be steep, a ramp or whatever, right? So we can set our slope to the angle we want it to be walkable, all the way up to 90 degrees. Obviously 90 degrees is a wall and should not be walkable. Then we have our step height. So how high between each step is walkable. So again, I mean, steps can be a certain height, or a certain slope, but if their step height is too great, it will also not be walkable. So again, these are for just automatic generations of being able to walk up steps and things like that. The generated off-mesh links we'll talk about in a second here. We're actually going to make some. All right, and then we have this advanced area where we're talking about the minimum size of a region, how much inaccuracy we'll support. Obviously, greater levels of inaccuracy will make our game more efficient, so it'll run more smoothly. And so if we turn this up, our games will run faster. If we turn it down, our games will be more accurate. All right, and then we can turn on whether or not we want to enable the height mesh. All right, and then we can mess around with these all that we want, and we can just go ahead and hit bake, and it'll bake our scene to those specifications. All right, so with all of that being said, let's go ahead and add another character. Let's add an enemy. All right, and so with an enemy, we will be able to have something chase us. So I don't know what you guys are talking about in chat, but you really should try to keep it on topic there. Yeah. Does baking save to disk? That's a good question. I believe so. I believe it bakes it into the meshes themselves. It creates a plane, right? So I believe it builds it into the models themselves when we bake it. I don't believe it creates a separate asset. I mean, it saves. So like if I bake the Nav Mesh, right, and I close my project and open it up, it's still there. So it is saved out, but I'm not entirely certain where the data goes. So that's actually a good question. I'm not entirely certain. But let's go ahead and create ourselves a zombie. So what I'm going to do is I'm going to go ahead and put our zombie way over here in the corner so that we have a fair advantage. I'm just going to grab a model. So let me come over here to models and let me grab this robot. That works. Little robot dude. We'll stick him all the way in the corner, give us the maximum advantage. And so he has an animator and stuff like that attached, but I'm not going to use any of that. Again, I could manipulate the animator through scripts, but I'm not going to bother with any of that. So what I'm going to do is I'm just going to put a Nav Mesh agent again on him. So I'm going to go to Add Component, Navigation, Nav Mesh Agent. So that's on him, and that's all I'm going to do. I'm just going to leave that. Well, actually, I'm going to turn his speed down. I'm going to make his speed 2, so he's not just as fast as us, because that would be boring. And then I'm going to go to Scripts, and I'm going to create a new script. And I'm just going to set this up to be a C# script called follow script. And all we're going to do is we are going to say every turn, follow the player. All right, we're not going to tell it how to follow the player. We're not going to tell it the path to take or anything like that. We're going to say follow the player, and then it's going to do so intelligently. All right, and so it's going to help us. It's going to move around. It's going to handle all that decision stuff for us. Is it possible to use this mechanism with a runtime randomly generated from prefabs, or only on a pre-made scene? That's a really good question. I believe we can only do it on pre-made scenes. There might be a way to manage it otherwise. Sorry, I gotta ban someone here. I gotta figure out how to get rid of somebody. There we go. Okay, grab Great. So don't spam. I appreciate it. I don't like taking time out of the live sessions just to not do all that crap. Okay, so what we're going to do is we're going to make a script for this guy, and all it's going to do is it's going to enable him to follow us around. So I'm going to click the follow script, and I'm going to drop it on the robot, and then let me go ahead and edit that. Nav Mesh on 2D, I don't know, actually. The 2D stuff is new enough that I don't see any reason not to. I don't see any reason we couldn't, but I'm not sure if the built-in components do that or not. I can find out. Message me on Twitter, and I will find out for you and let you know. I've only ever used Nav Meshes 3D, so I've never done them 2D, so we can find out, and I'll let you know. Okay, so for our follow script here, a couple things. Again, we're just going to need access to our agent, so I'm going to say Nav Mesh agent, which I'll call agent. All right, this is all kind of the same here. And then I'm going to say agent equals get component Nav Mesh agent, just like that. All right, and then I'm going to have a public transform, which is just going to be our target. In this case, it's going to be the player. And then every update, I'm going to say agent.setDestination target.position. Just like that. That's it. So all I need to do is every turn, I'm going to figure out where the player is because we have access to its transform, and we're going to go there. And that's it. And it's going to handle everything else for you. How would you handle a locked area or a path that is created mid-game, like a bridge is built or a wall is destroyed? So a couple ways we can do that. The first is that we can have, like, say there's a door, right? We can have a door block our path, right? And it will prevent you from going into a room or whatnot. Later on, when you have the key, when you trigger that door goes away, and you can go into the room, and all of that is fine, right? And that works all rather well. Excuse me. Another way is we can use this off-mesh links, which I'm going to show you here in a second. And the off-mesh links effectively allow us to allow the character to jump between mesh areas, or nav mesh areas. And we can turn those on and off with code. So if I don't want a player to go over an area, I just disable that link until the bridge is there, and then I enable it, and the character can go, right? So yeah, I mean, you could do that. Off-mesh links, we'll talk about those in a second here. But anyway, so let's get back to this. So I want to illustrate just the gravity of what I'm saying, of how fantastic this is, right? I basically have an agent, I have a target, and I say go to the target. I can just toss it away, and I don't need to mess with it at all. So let's go back to Unity here. The script won't be posted for download because the video will be posted. You can just watch it again. If you missed a part, just watch the video again. The script is actually really simple anyway, so it should be pretty easy to follow along with. Now, okay, let's duplicate him. Everyone keeps saying duplicate him, so why one robot when we can have an army? Army of angry robots. Okay. Ooh, before I do that, let me come back to him. I need to give a target, and I didn't want to have to click and drag the target a billion times. So where is Ethan? There's Ethan. Click and drag Ethan. So Ethan is the target, and now I will duplicate them. There we go. Rise, my robotic army. Ethan is in a big trouble. Okay. So now we have Ethan, and we have an army of angry robots. Let's go find him. So I'm just going to hit play. And again, note that all I did was just duplicate that. The guy's got a Nav Mesh agent on him. He's just every turn being told to follow Ethan. Survived. In case anyone was curious, I didn't die. Yeah, that's particularly weird. The video cut out there for a second, and it's back. Everything's fine on my end. I didn't drop any frames or anything. Yeah, we'll see. Oh, but my video reset here, so maybe something happened. Anyway, whatever. All right, we'll just keep going. As soon as I hit the lasers. Okay. So yeah, okay, so apparently a bunch of enemies really didn't like me getting away, and they crashed my streaming agent, and now I'm going to have to stitch two pieces of video together, which is always just sort of a pain in the butt. Anyway. Okay, so we saw how easy it was to make zombies. That's effectively what we did. Right? We can have a script when they're in close proximity, they'll bite the player or whatever, but now we can see how easy it is to use Nav Meshes to start the robots chasing you. Alright, you want to see the robots chasing me again? Hopefully I don't crash this again. Oh, I didn't mean to go in the room. But we'll see the robots will... I didn't notice how long the stream was out. So we can see that the robots are chasing me. They will intelligently path. They just happen to all be coming the same way because it's the right path to take. It's the fastest path. You can add a little bit of inaccuracy or variance to them so that they all kind of shamble and take different paths and stuff like that. But ultimately, right now, they're highly intelligent, and so they're taking the fastest path. And so that's, you know, why they're kind of moving around like that. And if we, place them a little bit different, they won't all be lined up like that and stuff like that. They're also lined up like that because our radius is higher, and so our paths are naturally smaller, and so they're gonna to line up as well. So real simple. I just dropped a couple models on. The streaming gods are angry today. Well, it's not the internet. My streaming agent hasn't dropped any packets or any frames or anything, so I don't know. Anyway, let's wrap this up. Let's keep going before the whole thing goes down for good, and I'll just figure it out later. So sorry about that, everybody, and now it's gonna be three videos. Yeah, that I'm gonna have to stitch together, which is a pain. So let's talk about off-mesh links. So basically, off-mesh links are a way for us to combine two meshes together, which will allow a character to bridge from one to the next. They're useful for things like bridges or doorways or whatever, where you don't have the mesh connected like this. They're useful for all sorts of things. And we can have them created for us, or we can place our own manually. And the thing about placing your own manually is that is a Pro-only feature. So if you do not have Pro, you will not be able to place your own off-mesh points manually, right? It's not generally a big deal. We can make do actually rather well with the automatically generated stuff, so it really shouldn't be a problem. So let's look here. Let's say, for our hypothetical situation here, I wanted the player to be able to move across from roof to roof or to jump down, right? You can see right now the player can't move roof to roof and the player can't jump down because the navigation mesh will prevent them from going anywhere that's not this lately shaded blue area, all right? And so we need to tell it, hey, we want to be able to move to these places. We want off-mesh links, okay? And so what I'm going to do is, first off, I'm going to change my radius back down to 0.3. All right, I showed you what that did, so now let's go back, and that's going to make it a little bit bigger. And so what I want to say is, I want to say, automatically generate these for me. Okay, so what I'm going to do is I'm going to click, I'm going to go back to object here, mesh renderer, and I'm going to click the rooftop here, I'm going to click the rooftop there, and I'm going to click the ground. Because I'm only really concerned about these three things. I could do this all over the place, but I'm just really concerned with this area right here. All right. And so what I'm going to do is I'm going to make sure off-mesh link generation is checked. All right. We got to make sure that's checked. And then what I'm going to do is I'm going to tell it what constitutes an off-mesh link, right? Because if I bake right now, you're going to see, I mean, it's all completely the same. Nothing happens. So I'm going to come over here to the Bake tab once I know this is checked for those three objects. And I'm going to see, hey, what constitutes an off-mesh link? And I'm going to say any drop, well right now it says any drop height that is 0 or less will generate a mesh link. Well obviously 0 or less is flat, so we don't need a mesh link there, so that's not helpful. So I'm going to say 5. That's just arbitrary, I just picked 5 at random. Alright, and then what I'm going to say is jump distance. How far horizontally in between constitutes a link? So again, I'm just going to say 5. Seems reasonable. What's everyone talking about in chat now? All right, stop talking about C# programming. You can find that stuff later. It's distracting. You guys are distracting me. I already have enough issues with Twitch dying all the time. So what I want to do now is I have The drop height is 5, the jump distance is 5. So now watch what happens when I click bake. I'm going to hit bake, and we're going to see a bunch of arrows appear. And there they are. They appear just like magic. And what these arrows are is these are the links, which means if the player happens to be in this circle, they will be able to jump to this circle, right? Or if the player happens to be on this circle, they can drop down to this circle, right? And so what that gives us is that gives us the ability to jump across the platforms and to jump down. These are those off-mesh links that we're talking about. A question here, what about one-way jumps, and what if one platform moves past the 5 distance? Well, then this stops working. And so again, that's a pro feature. Like things where you want to be like, this is a one-way jump, manually placing your own stuff. To do that, the manually off-mesh links is a pro feature. So, yeah. I do need someone to moderate. You aren't kidding, man. This chat. So, the automatic placement is free. The pro placement, the manual placement is pro. All right, so you can do everything I've done here today with the free version. All right, I'm not going to cover the pro features because they tend to get pretty convoluted and such. And you really, trust me, I mean, unless you're building a very specific scenario, you're not going to need it, or you're going to be able to do it with code anyway. But let's look how this works. All right, so what I'm going to do is I'm just going to go ahead and grab my guy here, and I'm going to move him. And actually, I want to grab him and the camera at the same time and move them both. This is going to let me move them both. Where's the camera at? It is. Fantastic. So what I'm going to do is I'm just going to move Ethan over here, and then I'm going to put him up here. Ethan doesn't have a jump, which is why I'm just manually placing him. Because if I didn't manually place him, I'd have no way to get him up on the roof. So there we go. And I'll hit play. Ethan is on the roof. How embarrassing. Now, if Ethan wants to get to the other side of the roof, boom. Now, it doesn't look fantastic. That looked dumb, trust me. I get it. But it happened automatically. And so I will take a little bit of dumb for a lot of easy. All right. Now, we can detect in code when Ethan gets to that off-mesh link. And at that point, we can make him play some animation. We can be like, hey, Ethan's about to jump from one link to a next. Play our horizontal jumping animation, right? That all works completely fine. And that'll prevent the really dumbness of how that looks, right? But again, it's working, right? Which is what's cool. The AI is working. The pathfinding is working. So the animations are a little rough. That's fine, but that's not really, you know, what we're talking about here. Anyway. Yeah, roof to roof jumping is still free, so don't worry about that. It's manually creating those links. That's the problem. And I can also get down. Now again, that's not super graceful. I get it. You can play a jump down animation if you need to, right? And now I'm just running from zombies because these zombies are all over me. Now wait, and actually I just saw something cool, so I'm going to show you this here too. I don't know if maybe cool, maybe not, but something I noticed. I'll let the zombies catch up here. I got to be careful because my video is going to go down in a second again if I keep doing this. The zombies are going to jump across these obstacles. They did that. They jumped across the obstacles because, as you can see over here, off-mesh links were built because they met my threshold, right? So if you did not know how to, or you didn't want that to happen, you'd kind of be in a bad way. Are you sure off-mesh links, the automatic ones, are not free? I'm pretty sure they are. It says they're not on the documentation, but that documentation page is old. It should be free. I'm pretty sure it's just the manual ones it's not. I might be wrong. I'm sorry. If I'm wrong, then I apologize. I don't believe I'm wrong, but it's happened before. It's happened at least once in my life that I was wrong. So, yeah. If you're curious about the camera in this scene, just download the Stealth project and look at the camera. I don't know how they built it. There's a script on it that makes it do that. You'll have to just check that out for yourself. Okay, but as you can see, that's what off-mesh links are. They just basically link between the two. Realistically, if you didn't have off-mesh links, you could put a trigger on the corners, and when the player entered the trigger, you just played the jump animation, you moved them to the other side, kind of like a jump pad. That would certainly work as well. Yeah, and so, you know, there's a lot of different ways you can handle that. All right, so at this point, it's been just a little under an hour, but I'm going to go ahead and wrap up because I don't want my video to crash again here, and I've got to to build it all build it all together anyway. So this video will be compiled and placed on our site. So don't worry if you didn't get a chance to see it all, or if you had some issues. It will be available for you to try out. Let's go over. So what we talked about today, we talked about the different navigational issues in pathfinding algorithms. We talked about what a nav mesh is, and I showed you how to build one, actually fairly simply. I showed you how to add a nav agent, and I showed you how to move the nav agent with script, and then how to create zombies to chase our character around and stuff like that. We talked about off-mesh links, and we talked about navigationally static items in our scene. If the just looked in 4.3. You know what? Everyone's saying that it's not free, but I was just wait 1 second here. Now you guys are making me. Now you're making me figure stuff out. Going to the license comparison page. See, Nav Meshes pathfinding and crowd simulation is both Unity and Unity Pro. On our website it says that. I don't know where you're seeing the other stuff. So, yeah, anyway, on our site, on the license comparison, it says Nav Meshes and all that stuff is Unity Free and Unity Pro. Anyway, I'm not going to hold you guys up anymore while we discuss this. But if you liked the session, any questions, comments, concerns, please follow us, message us, talk to us on Twitter, at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at the Ant Ranch. I do apologize for the technical difficulties we had today with the videos. I hate when that stuff happens, but sometimes it happens. Not a whole lot we can do about that. Yeah, thank you all for watching very much. Have some fun with Nav Meshes. Get your zombies chasing you around and have some fun with that. And thanks again for watching. I will stick around and chat for a few minutes here so we can talk, but otherwise I'm going to go ahead and end the stream, and thank you all very much.